Let's go through code 945, minimal increment to make array unique. For this question, it give us integer array nums and ask the minimal number of increment to make this array unique. So the number of increment is that we can pick any number and increase the number by one. That is one increment. So ask us what's the minimal operations. So for example, the first example, if we make any of these two to be 3, right, that we need one increment. So the result 1 to 3, they are unique. And the second one is 1 to 3, 1 2 2 1 1 2 2 3 7, right? So we can put this one as 1 2 3 4 5 7, and then so that need one of 1 to be 5, right? One of the 2 to be 4. So what we thinking about is that we need some kind of strategy, right? So for example, assume we already have this data sorted, right? And then we also have counts. For example, the 1 appears twice, right? 1, this is 1 appears twice. And 2, this appears twice, right? And then 3 appears once, right? And 4 and 5, this is empty. And 6 is empty, right? And 7, there is 7 appear once. So what we think about is that we can use some kind of map or do to count, right? For example, tree map. Or we can use a bucket, right? Because for this question, the data range is 10 to the power 5, and the number length is 10 to the power 5. So if we use bucket, should be a linear, right? Linear time complexity. So what we think about is that if we use bucket, we also need a statistically count the frequency of the number, right? And we can open 2 multiplied by 10 to the 5 length array. Yeah. Then what we do is that we count this, right? Why we open this kind of length is that we know, for example, we have from 0 to 10 to the power 5th, right? And the worst case is the 10 to the power 5th number at 10 to the power 5th, right? So that means if we keep one of that, then 10 1 1 0 0 0 1, right? To 2 multiplied by 10 to the 5th, and we are move this kind of number here, here, here. So 2 to the power 5th, the length should be enough, right? So we keep it 1, so we just need to have 9 9 9 9 slot. So from 1 1 to 1 9 9 9, right? So we open our array to 10 to the power 5th should be enough. Then if we already have this kind of arrays, counts array, so what we do, well, how can we need some kind of strategy, right? So for example, we have a lot of zeros at the beginning, but at 5, right? For example, this one has counts 10. What we should do? And for example, 6, it has counts 3. And 7, it counts 2, right? And then 8, if this is empty, there is an empty slot here. And for example, 9, there is empty slot. And for example, 10, there is 1 here, right? So what's our strategy? So what I was thinking about that we should have 2 pointers. use pointers. One is we call left pointer, right? Another is right pointer. We use J, right? And so we know because what J do is that we find us an empty slot on the right of I, right? So what we do is that we need a J's index to be at least I, and then if we are keeping moving, right? So for I, we can only put one here, right? The 5 ones here, but the thing is that we have 5 this number appears 10 times. That means in the right we need to find 9 empty slots to have this kind of number to put into, right? So what we do is that we keep moving our J pointer, trying to see if there is empty slots until this kind of 9 counts. We call needs, right? We need 9 empty slots. Until this 9 needs has been filled by these kind of slots, then some J may be stopped here, right? And then if this one has moved, right? So every time we find an empty slot, we are add the J minus I to our result, right? That means that we need those kind of moves. And then we move our I pointer, right? Then for this one, we need 2 more slots, right? Then J keep moving, right? In some of the scenarios that there may have a lot of space for J, right? For J, and then the I will bypass the J, right? So in that case, we should have J to be keep as to be at least I, right? So until this kind of I has been moved, so I just need to iterate to the max number. Okay. So let's write code for this. We know if we use a slot, then we don't need the sort, right? We just need a open a new int. Also choose this kind of range, right? And we have every number in nums. We are going to have count num increase by 1, right? So we need to have our result equals to 0, right? And then let's have J index to 0. So what we do is that for int I equals to 0, I smaller than 1. Of course, we can have a max, right? So that it will we just can terminate at max. But if we put smaller than small equal to 10 to the power 5 or smaller than this, it is good as well, right? I plus plus. So we'll say this J should be at least I, right? So let's put this. So if counts I is smaller than smaller equal to 1, right? That means for this kind of I, we don't need extra slots, right? Then we don't need the extra slots, so we just do continue. And so we need these kind of slots for this I. So that is the count I minus 1, right? Then for this I, we are doing while loop for this kind of J, right? So J is trying to keeping find the empty slots while needs is greater than 0. What we do is that we have moving J, right? And if count j equals to 0, then we'll have needs decrease by 1, right? And also every time, if we find a slot empty, we'll have result the plus equal to j minus I. In the end, we just return result. Let's write this as a Python code. So let's have an count equals this one multiplied by 2,000, 200,000. And for num in nums, we're going to have count num plus equal to 1, right? And we have result j 0, 0 for I in range 1, 1, 1, right? Then we are going to j equals to max j in I. Then what we say, if count I is smaller than 2, we just continue. Then what we say, we'll say there needs, right? Needs equals to count I minus 1. That means we need on its right this kind of slots. Then we'll say, wow, this needs is greater than 0. What we do is that should we increase the right pointer, right? And when we increase the right count pointer, if the counts j equals 0, means this is an empty slot. Then we have needs minus equal to 1, and the result should plus equal to. That means this I should move to this j's position, right? And in the end, we just return result. Okay, why this so slow?